Okay, so for question 3, we have to find the coefficient of lift for different angles of attack. And then we're going to do that for all the different miles per hour and then all of the different configurations that we have here. So you should have 3 graphs in the end for this, where we have one graph for 20 miles per hour, one graph for 30, and then one graph for 40 miles per hour. Then on each of those graphs, you're going to have basically 3 different curves where you have close and close, open and close, and open for the slat and flap configurations. Okay, so then the formula that we have to use is right here for this coefficient of lift. So if I go to your MATLAB code, and what I did is I kind of made this text larger, so hopefully you can read it. I'm going to comment out your code right now, and that's highlighting and then doing Control R. I just found that out, so pretty useful. And then if you want to undo that, you highlight it all and then do Command or Control T. Okay, so question 3, coefficient of lift. Okay, so what we're going to do is we're going to start off by doing for I equals 1 to 6. So we're doing that because we have 6 different angles of attack. Okay, and then we're going to do for j equals 1 to 3. And then this is going to be because we have 3 different airspeeds. Okay, so you had 2 wind tunnels, so we don't need to do that. We're going to use data from wind tunnel number 1, and that's going to basically be for our free stream air velocity. So you don't have to solve for this because we already did that up here. VO1, that's the free stream air velocity for the first wind tunnel, and then VO2, that's the free stream velocity for wind tunnel 2. And then we also know the free stream air density, that's just rho A. So if I go back to the formula, right here we have the density, we have the velocity, and then we also have the lift force, and we have the planform area. So AW right here, and then the coefficient of, or the lift force, we had that measured as well. And you have that here. Okay. So basically what you're going to do is you have those, and then right here you have k equals 3 plus I minus 1 times 2. That's almost correct. Basically what we're going to do is use the same logic down here in question 4. So we're going to have k equals 3 plus j minus 1 times 2. And that's going to give us airspeeds of 20, 30, and 40 miles per hour later on in the code. I'll explain this in more depth. Times 2, and then I'll make a comment. Okay. Let's suppress this. Okay, so we have that, and now all we have to do is solve for the coefficient of lift for each speed, basically, and then we're going to do it for each configuration too. So how I'll set this up is CLC, and we need to do that for I and J. I'll do CLF, IJ, and CLS, I comma J. Okay, so basically what we're going to do is we have these, we already have an array for this. We have zeros right here, so we have CLC, CLS, CLF. That's for our different slat and flap configurations. Again, then now all we have to do is just type out the formula that we have right here. And so basically, for that, you're just going to have to type it out. So you're going to have to iterate for the lift that we have for I and j. So I'll just get this part started as well. So we'll do 2 times LC I comma j. So we're doing that because we had, again, 6 angle of attack, and then we had 3 different airspeeds as well. And we need all of that for our plot later on. So we're doing 2 times LC for I and j. And then we're going to, and I'm doing 2 times this lift force. I'm just bringing this 2 on the top. Okay, so then we have 2 times the lift force divided by the free stream air density. So rho A. And then we're going to have to multiply that by the velocity that we have. That's going to be squared. And then we're going to do times the planform area. And we'll suppress that. So let's go back here. All I've done is typed out this formula. However, we have 3 airspeeds here. We have 20, 30, to 40 miles per hour. So for that, okay, let me open this up really quick. Okay, so for the airspeed that we have 20, 30, to 40 miles per hour. That's what we need. And we're basically getting that basically from this sheet here. So, or if you go into MATLAB, you can kind of see it there. So let me run your code. Okay, it's going to do that because of this. Okay, let me comment these out. Okay, that's because I don't have your Excel sheet. Okay, let me run mine. I'm gonna comment out all of these plots though. Or I'll just run it. That's fine. Okay, have that go. Taking a while. Alright. So if you were going to go to your velocity that you had, you would see that you have 7 values here. And if we kind of correspond that with our Excel sheet, that's with all of these right here. So that's 10, 15, 20, 25, 30, 35, and 40 miles per hour. But we need to have 20 and 30 and 40 miles per hour. So we did the same thing in question 4 right here. So we need 20, 30, and 40 miles per hour. So for the velocity, in this case, using wind tunnel 2, we have to iterate that with this k variable here. So that could select airspeeds of 20, 30, and 40 miles per hour. So we need to do the same thing in question 3. So basically right here, I'm going to put a k. And then you just need to do that same kind of logic for the next 2 parts. So you're going to do 2 times LF here, and then 2 times LS in the bottom part. And then the rest of the code should be the same. So I'm just looking at my code right now to make sure I typed everything in correctly. Okay, yeah, looks good. So that's all you're going to have to do, and then you'll be able to find the coefficient of lift for this stuff. Alright, so let me know if you have any more questions.